Hello, ladies and gentlemen, it's Mike here at Gamefromscratch, and today we are talking about a brand new console-grade open-source game engine from Toyota. Yes, that Toyota. It's called Fluorite, and this one is going to occupy a very special or specific niche because it is integrated with Flutter. And we're going to go through why they chose this, why they didn't choose other game engines, etc. But first, a quick overview of Fluorite game engine to start with. Now, one thing you got to know about this one is it isn't existing yet. It isn't publicly available yet. So the source code is not out there, but they announced this at FOSDEM, so I'm going to assume that the source code is coming at some point in the near future. So at the core, there is a high-performance ECS core. So it is written in C++, so this isn't written in Dart, which is Flutter's native language. It is C++, so it should be high performance at that level. Then you've got some very specific things here. This is their second highlighted feature, is model-defined touch trigger zones, enabling 3D artists to define clickable zones directly in Blender. By the way, Blender comes up quite a bit and seems to be the center stone of their DCC tooling, which we'll get back to in just a bit. But it simplifies the process of creating spatial 3D UIs. And then again, console-grade 3D rendering. This is actually going to be very cross-platform, available on consoles as well, including desktop environments and mobile environments as well. So it's going to be powered by Google's Filament. We'll get back to that a little bit. Another key part, thanks to the Flutter and Dart integration, is it has hot reload, so you can just update your scenes as you change them, see them immediately as a result. And then more details are coming soon. So we don't have a lot to go on here, and I did mention Toyota. Look down here. Copyright 2026 Toyota Connected North America. So a few things about this engine. First off, it was presented at FOSDEM 26. So if you want to watch the video behind it, it is available here. They go through all of the reasons behind this engine. I actually pulled all the slides out of that, and we're going to go through them instead, save you a little bit of time. So why did they do this? Well, first off, they're building on a project that they've already created called IVI Home Screen, which embeds Flutter's runtime to native Linux with Wayland support. And this is being used already in the Toyota RAV4 2026. There's one big downside to this implementation, though, is that there's support only for 2D, static interfaces, limited UI UX capabilities, which is why they're ultimately building a full-blown game engine instead of just having this IVI home screen integration of Flutter. So, use case for a game engine inside of a digital cockpit. And this is kind of getting more and more common. Actually, right now, Unity, Unreal, and Godot are all actually being used in production cars for the heads-up displays or, the various different interfaces that are involved with it. So, what do you've got? Step-by-step 3D tutorials, hardware state visualizations, environment mapping, more natural controls and interaction, and enabling competitive designs. That's why they are building a game engine for cars. So why did they not use the existing game engines? Well, they broke it down by Unity and Unreal. They require shipping proprietary blobs. Multi-view requires spinning up multiple engine instances. They are resource heavy, resulting in low frame rates, and they have high licensing costs. They also looked at Godot. They chose not to choose it because it took too long to start up on Raspberry Pi, and also resource heavy. Now, this one strikes me as a little weird because instead of creating your own game engine, I would have thought you'd be able to optimize startup speeds. But anyways, that's why they didn't choose Godot. And then for Impeller Flutter GPU, no idea what that is, to be honest. Unstable on most platforms, and it is immature, which is probably why I have never heard of it. So the technology behind this, well, we have SDL3, we have the Flutter on Embedded, which is the IVI home screen, and MetaFlutter projects together. The Flutter SDL3 Embedder is working for the cross-platform I/O, and then Google's Filament 3D rendering engine is being used for the real-time physically based rendering aspects of this engine. So, back to what they featured earlier on. Key points of the engine. One of them is high-performance ECS core. So, it is written in C++, but is optimized for low-end hardware. It's got a hierarchical scene graph and transferable knowledge skills from other game engines because, well, we all know what an ECS is at this point in time. Again, back to that. And then we've got the console-grade 3D rendering. They're using Google's Filament 3D renderer, which has embedded optimized PBR assets and lighting, and customizable shaders and pipeline. Again, hot reload being one of the primary features. These are things that are coming soon, so things are still being worked on. They are going to be integrating Jolt Physics. Now, Jolt Physics are actually, they were used for Horizon one of the Horizon games, maybe not Zero Dawn, but one of the series of Horizon games uses Jolt Physics as an example, and Jolt Physics is now the default physics engine in Godot as of Godot 4.6. So they're going to be integrating Jolt Physics for their physics interactions within the engine. And then this, again, is kind of interesting. They do seem to be building entirely around the idea of Blender. So creative workflows, tooling and UI to support designer-developer collaboration, open formats, Blender compatibility, GLTF, KTX HDR, and GLSL, and easily portable assets from other game engines as well. So should be good to fit into existing workflows, etc. Now, a bit of an overview of all the various different technologies that are going together here to create the Fluorite engine. The obvious key one is Flutter. This is a Google project. So it is for creating kind of write once, run anywhere user interface applications, kind of the next evolution of that. So it's open source framework for building beautiful natively compiled. That is the key part. So they're still built and compiled, then they're not a runtime here. Multi-platform applications from a single code base. I've never actually developed using Flutter, but there are a lot of people working with Flutter, including, hey, Toyota. The other aspect is Dart. Dart is the programming language that is behind Flutter scripting. Dart is kind of the closest equivalent to Dart is TypeScript. It's kind of a better JavaScript concept to start, and it's evolved into something much more than that now that you've got things like AOT or ahead of time compilation, so you can do native machine code, but you can also compile down to JavaScript and WebAssembly. So again, a lot like TypeScript in the way that it was first introduced. You can go ahead and play with Dart if you're interested. I haven't done a lot with Dart. I played with it a little bit after it came out. I don't really know how it has evolved since then, but the biggest reason why Dart even has any viability right now is the popularity of Flutter. So Flutter has made Dart what Dart is today. But from my experiences using it in the past, it's a fairly straightforward syntax. It did not seem like a difficult language to learn. The other thing, again, is the IVI home screen. This was developed by Toyota. It is a way to embed Flutter into embedded Linux with Wayland windowing support. So you can see details of what it does right there. So this is a Toyota developed project that they are already using right now for the user interface for the RAV4, that is currently the 2026 RAV4 is using this for its user interface. Again, it is limited to 2D only, which is why they are moving beyond it into the world of 3D. Now, for all of the things like touch handling, input, possibly sound, etc., they are using SDL, specifically SDL3, which was released within the last half a year anyways. And then again, this is a super popular library in the world of game development, and a lot of game engines, including Valve's own source engine, actually use SDL for a lot of these things. And then the other key player here is Filament. It's a real-time physically based rendering engine for Android, iOS, Windows, Linux, macOS, and WebGL2. So this is what they are using for their 3D rendering. This is a Google project that is ultimately behind Google Filament. So you can see the capabilities of it. This is a lot of the game engine rendering side of things is being handled, obviously, by the Filament thing. So they're bringing a lot of really popular cross-platform things together. Flutter, SDL3, Filament, etc. So they're not building this game engine completely from scratch. And then, of course, Jolt Physics. This isn't in there yet, but it is coming soon. So we go. Horizon Forbidden West. Also Death Stranding 2, and again, it is now the default game physics engine inside of the Godot game engine. So very popular physics engine right there, runs on a number of platforms as well. And that, ladies and gentlemen, is it. That is the Fluorite game engine. Yes, Toyota is entering the game engine world. Hey, you know what? More choices, always a good thing. And the world of interactive displays, using game engines for car displays, it's already a thing. So I guess this does make a certain amount of sense. But the interesting thing is they're actually going to be targeting multiple platforms, including game consoles. So let me know what you think of the Fluorite game engine in the comments down below. I'll talk to you all later. Goodbye.